Good afternoon, folks. Welcome to our session, The Governed Open Lakehouse, Achieving Interoperability and Unified Context. I'm Vinod. I'm a PM at Google, and I'm presenting with my colleague, Ahmet, and our customer, Sumeet Singh from Viasat. So let's get started. The agenda for our talk is first the evolution of Open Lakehouse and Lakehouse architectures over time, Google's position on the Lakehouse, and discussing our AI-native cross-cloud Lakehouse. A key demo covering some of our key announcements that we have done in this conference, as well as hearing Viasat's Lakehouse story. So let's get started. Evolution of the Open Lakehouse. When we look at the key problem that we see organizations and customers solving, 92% of the customers and organizations we talk to are doubling down on their AI investments to tap key insights from their data. However, only 70% of them are really able to tap the potential of the data, and 70% of this data is probably not correctly unified and not correctly organized with governance. Furthermore, 80% of this data is kind of unstructured and multimodal and is not really tapped, and organizations are looking to ways to get more insights from this data. Over the industry evolved with Lakehouse 1.0 to address some of these problems by switching to freedom with zero vendor lock-in with open formats, to avoid migration hurdles and bespoke pipelines, and providing interoperability across key analytical systems with an open source community. Along with that, Apache Iceberg grew as a standard in the industry. We at Google Cloud have ourselves seen 3x growth in Apache Iceberg adoption among our customers. Customers really love Iceberg for its openness and interoperability, and simplicity and convergence of data for AI use cases. However, as they evolve in these Lakehouse architectures with Iceberg, customers still face key challenges for their enterprise use cases. For example, advanced real-time data processing and streaming, customers build bespoke pipelines such as custom Kafka architectures, or streaming use cases where they have to come up with architectures to handle the small pile problem, and building it at scale. Furthermore, when they're building at scale, they have to work through custom catalogs, having governance across the different tables and formats across their catalogs, and they run into challenges in having this unified governance. Furthermore, the need for advanced runtimes and differentiated price curve, especially for their AI use cases, needing context for grounding their AI agents, and so on and so forth. So while customers have built Lakehouse 1.0 architectures, they still need help solving these key problems for their enterprise needs. And from that perspective, customers are evolving from systems of intelligence to systems of action, where they want to move from human scale to agent scale, from reactive intelligence to proactive action, from data to semantic knowledge. And that's where we at Google offer the AI-native cross-cloud Lakehouse that enables customers to address some of these key pain points for their key enterprise use cases. Our AI-native cross-cloud Lakehouse provides for openness with zero compromise. All the challenges around streaming, scale, performance are addressed without the trade-off of compromising on openness. Furthermore, it offers a broader, borderless cross-cloud foundation wherein you can access your data across clouds, so any data, any formats, with key insights. In addition, it's built for the agentic era, so you can have access to context in your key agentic ecosystems and transcend analytical and operational use cases as well. So that's the evolution of the Lakehouse from 1.0 to the AI-native cross-cloud Lakehouse. Furthermore, we've evolved our Lakehouse from Big Lake to Google Cloud Lakehouse from this perspective. Our Lakehouse is a ground-up stack with AI-native compute, differentiated storage on cloud storage, but access to storage from other cloud providers as well. Furthermore, you immediately get access to your data through our runtime catalog, as well as our knowledge catalog, to be accessed across key analytical systems such as Managed Spark, BigQuery, as well as OSS engines. You can also access it in your operational databases. And all of this in an agentic ecosystem within Google Cloud with notebooks and an integrated IDE experience. And now, I'll hand over to Ahmet, who will deep dive into key areas.
Hello, everyone. Thanks a lot for showing up and choosing us over the concert. Really appreciate it. And I will give you some secrets about how do we make this without compromises to make it worth your time. So let's get started, right? The first thing I want to mention is that, right, as you know, right, just because a tool is open doesn't mean that it comes with all the niceties of what you are used to, right? All the Lakehouse tooling, all the performance optimizations, reliability, everything we have built in 20 years doesn't come by default just because it's open. So there is a choice, or there has been a choice, right? If you go to any of the vendors' websites today, you will find that there's a table A, there's a table B, there's an open table, there's a performance table. And this is a problem we have been working on in the past year or so, and we have been addressing it. First, I want to talk about what we have built, where is the momentum, and where we are going. At the very core, we have what we call so-called managed iceberg. This is our ability to read and write into tables. This is the standard Apache Iceberg that you know, that we are managing it for you. And on top of it, we are bringing everything that you are used to from BigQuery, whether it's advanced runtime, partitioning, reliability. These are performance optimizations you can have on Iceberg. Finally, well, you need to bring your data somehow. We are obviously integrated with every possible way of bringing data in. DTS is an example. You can ingest your data into our managed Iceberg. This is not sufficient because Iceberg is a storage format, and it is missing a control plane, right? We unbundled storage from compute. That's great, but we are missing a lot of features. Iceberg REST catalog emerged as the new standard for being the catalog control plane, and we have been tagging on to that, and we start building Lakehouse catalog. And Lakehouse catalog is fully Iceberg REST catalog compatible, which is great, which means that if your data is here, you can access it through various other means. And if your data is somewhere else in Iceberg format, we can also access it with various, from wherever that might be. Table management this is again an interesting topic that came at Iceberg-related discussions at Iceberg Summit. We unbundled the storage, that's great, but we pushed on too many responsibilities to the users as the open source community. Right now, users never have to think about, oh, I deleted a row, now I have to go delete files. I have to compact my Lakehouse. These were not concerns that people had to think about, and they should no longer be concerns within the Iceberg either. Right? So what we are saying is, if you are using our managed Iceberg, we bring all the table management that you are used to. You can still have your Iceberg tables fully interoperable with whatever you would like to use, and we will take care of what you are normally used to from a typical lakehouse, like warehouse, like BigQuery. Finally, we are making this AI-enabled. Like Object Graph is a key piece here. So if you have data on GCS in an unstructured form, and if you want to join your tables, you can do it on BigQuery. You can do it on BigQuery with Iceberg as well. Another point that I think it will be relevant to some of the customers here is that there's operational databases. And look, we have a very interesting opportunity with Iceberg. Right? There's a standard open storage format. And the next obvious question is, could we access the same storage format from different systems? And the answer is yes. And what we made it easy is that you can use LODB or Cloud SQL or whatever operational databases you have that's Iceberg compatible, and you can access the data. So now you have a system that's easy for you to back and forth move data between operational databases, your warehouse, and this is like automatically all tooled, managed, reliable. And on top of it, you can do things that are not easy to do in Iceberg, like you can do multi-statement transactions. So the reason I had this slide here was this was the momentum. This is what we have been doing in the past year. And now I would like to go where we are going. One of the very things that we are announcing in this event is that read-write interoperability. If you know the details of Iceberg, right, you will understand why this is important, but it's worth covering. As I mentioned, if you go to the website of any of our vendors, and including us up to a week ago, you will find 2 table types, because it is hard to create an interoperable table that's both open and performant. So we have solved that problem. There's a single table type. You don't have to choose. You can read and write into that table type from whatever open systems you have, whether it's Spark, Trino, or some third-party system. Or you can use our first-party tools, like BigQuery or Spark, and you will get the best performance in either case. So this is completely cross-engine operable. Everyone can write. We will manage the concurrency. And finally, I'll get into details. We are vertically integrating such that you can get AI optimizations. And why this is important is, like, if you think about, again, BigQuery, compute and storage is vertically integrated, which gives us a lot of advantages. And once we separate out Iceberg as a storage, we lose some of that, but we are making it such that we work vertically across the stack, such that you get the best Iceberg experience. Your Lakehouse experience is as good as any Lakehouse, any warehouse that you are used to running. Some niceties that comes with it, right? So whatever you do, obviously well integrated, fully governed, authentication is there. Table management we just talked about, we will manage the table for you. You have all the access controls, right? You wouldn't have to think about separately about how Iceberg tables are managed and authenticated, echoed versus BigQuery tables or some other thing. And this is the vertical integration with storage bit. This is interesting to me, that anything that happens in the GCS site will be available to you as users. Like some examples of that is AutoClass to reduce costs, or anywhere cache to move data across. But one of the things that I'm most excited here is the rapid storage. And why it matters is, it means that in Iceberg, we can separate the data that we want to access quickly, metadata, and put it on SSDs. And the data we need less frequent access on regular GCS buckets, which gives an extremely cost-optimized way of setting up the tables, and in a way that, like, it reduces latency and gives you a much more performant operation. And we do this, like, automatically for you as long as you opt in between our Lakehouse product and this storage stack. And adding on to the benefits, right? So that is BigQuery is an advanced runtime to run things faster with lower latency, high throughput. You get that when you use BigQuery with Iceberg. We have a managed Spark service, which is optimized for running Spark on GCP. You get that. The data science experience, whether it's Data Studio or the SQL experience or the Spark or whatever the tooling, the natural language to SQL generation, you get all of those things. And we talked about object graph, right? If you have unstructured data, if you have a system that collects PDFs and you want to join that PDFs with whatever account information you have, you can do it because it's also part of the system that we are providing. So the message that I'm trying to pass here is, whatever set of features you have in BigQuery, you are getting it on our Iceberg Lakehouse with all the benefits and all the interoperability of an open source system. And on top of it, right, Iceberg has a lot of gaps in terms of where it is because it separated storage from compute. And multi-statement transaction is one of the things that I explained. It is just not possible today in Iceberg. We make it possible as long as you are within our ecosystem and you are using our interoperable Iceberg tables. High throughput streaming is another area. We in the Iceberg community are trying to solve this as well. We are trying to push the spec. We are trying to make the open source a lot more streaming friendly. But until we get there, you get all the high throughput streaming and CDC benefits of BigQuery. And again, repeating, while you are getting this, your Flink and Trino is still working fully interoperable with whatever the Iceberg open clients that you are using. And finally, we can replicate data between operational databases and the Lakehouse. I would like to touch on Lightning Engine as well. Lightning Engine is managed Spark on Google Cloud. And I have to carefully read this sentence because it has been written very carefully. We are 2x faster than the leading high-speed Spark alternative. Show me your hands. Does anybody know who is the leading Spark alternative here? Well, you probably know. I can't say it. But we are 2x faster than that. We are 4.9x faster than open source. And these numbers might seem to raise questions. And let me explain how we get there. How we get there is we took Spark, we took Iceberg, we modified them such that they work best with our I/O, best with our internal systems, best with our layout. We added intelligent caching. We are even enabling certain BigQuery features like special smart metadata caching, making it available to the Spark engine such that query optimizations, query planning could happen in a much better, faster way. When we enable this, when we benchmark, we get these numbers. That is the path we are getting there. To sum up like what I've said so far, we have built the most interoperable system that works with any open source system. And then we took the time and energy to vertically integrate from the engine, BigQuery, Spark, the Lakehouse, GCS. Well integrated, reliable, performant with all the features while it's compatible with everything that you use today. I would like to touch on cross-cloud. The reason I'm going to touch on cross-cloud is, the reason number one is this, that we have been told by the survey that 91% of you are using multiple clouds. Those 9% of you, can you show me your hands who are only using one cloud? Well, it's okay. There's one, two. Okay, maybe it's 9%. I was worried to ask this question the other way. It would be hard to count 91%. So this is number one reason that there's a lot of demand in terms of customer needs that there's cross-cloud. The second thing is we think we are the best cloud operator with the best data analytics solution. So we would like those data analytics workloads to be on GCP. But at the same time, we understand that your data has been wherever it was for a decade. It's hard to move that data. But we have a compelling product with Gemini, BigQuery AI. I like BigQuery, the interface and usability. TPUs are there. So there's a lot of reasons to use BigQuery. So we would like to make it easy to access that data. Right? That is our product, cross-cloud. What we are trying to accomplish is give you reliable, fast, consistent experience wherever your data might be. And how do we do that? At the core of it is the Iceberg REST catalog. Iceberg REST catalog, as I talked, is emerging as the control plane. But beyond that, it gives us this additional ability that now, OK, there's a standard protocol. We can go and query the data in other places. We can find the metadata in other places. So if we truly think we have the best system, why don't we go and get the metadata from everywhere else for you? So you can, whatever your catalog might be, you can use Iceberg REST catalog without any additional effort. We will do full metadata replication for you. Not data replication, right? So we'll get you incrementally. And once you get there, the first thing you will get is, in addition to all your tables being in our system, you will get access to the knowledge catalog. Knowledge catalog, previously called Dataplex, is getting a lot more importance in this ecosystem because of agents. Because agents need a lot more context. And through our catalog integration, we can discover all your tables, all your metadata, parse it, pass it to knowledge catalog. Suddenly, whatever you want to run on Gemini has access to a lot more information. A common use case is you might be using Gemini with some tooling. Your data is in AWS. Now your Gemini has a lot more information about what tools to call, with what information to call, with what tables to call. And we have also done the work of integrating with partners. So I will show you the list, but at the same time, I'm going to list some of the major ones. You will see that all the major Lakehouse operators, Snowflake, Databricks, AWS, Confluent is integrated with us. We can read and write two-way exchange metadata. We have done the work with integrating with SaaS providers, SAP, Salesforce, Workday. And it goes on. We have done the integration with a lot of partners. And it doesn't end there, right? We have an open standard protocol, and we have a great opportunity, in my opinion, as a community to be a lot more interoperable And this is the way, the protocol is there, and we are able to integrate with all these people. But if the logo you are looking for is not there, it is super easy for them or us to integrate with them as well. Because there's nothing special, nothing hidden. This is all happening in the open. And obviously, I can't finish a presentation without talking about agents. Let's talk about agents. And I'm going to connect this, how it relates to agents and how Lakehouse is relevant. The first thing I think it's important passing here is, well, agents needs context. I already mentioned that. Going through knowledge catalog is able to gather a lot of context for us, and we will automatically gather that context for you so that your knowledge catalog can go and show those things. And finally, once everything is connected, you get a fully governed Lakehouse. Your knowledge, context, authentication, everything is enforced, search is there, indexing is there, and you have a full, complete picture just by using our catalog. A lot of things just follow from there. And every data engine that we provide obviously works. This is very similar to every feature we provide obviously works. With that, we'll show you how all of this comes together. This is the moment that you cross your fingers and Vinod presses the button. Thank you.
Thank you, Ahmet. Amazing set of exciting announcements, and now we'll see them in action in a couple of live demos. So let's talk about a key use case, and let's set the context. Imagine a fictitious retail commerce company, such as Look Commerce. You recently launched a product which is doing really well in the market, but you see that some of the products that were launched, there's like a return rate, about 5%. And the marketing team wants to understand, hey, what's going on? Like, what can we do to mitigate this problem? And can we build this through an Iceberg Lakehouse? So let's dive deeper into the use case itself. We start with an open Lakehouse on Apache Spark. This is a completely prompt-driven notebook. So, like, for example, here's an example on how you can build a notebook inside our IDE, where you take a prompt and just use Gemini to generate the code snippets. So in the interest of time, I've kind of completely built the notebook. But you can see here that it's pretty easy to use. You just start right away, prompt it with what you really want to do, and then you can start setting up like the Spark connection and so on and so forth. Under the hood, we are using the Lightning engine that Ahmet mentioned with the 4.x performance. So here we are actually setting up the Iceberg REST catalog along with the access to GCS file I/O with differentiated performance and security using credential vending. Once the catalog is wired up, we actually load all our retail data into a set of Iceberg tables. So we have the total retail return list. We immediately access this data, and then we want to combine it with the products data. So we get the products information as well, and then kind of start classifying these retail tables and over a certain period of time. So to actually create the retail tables, we create a catalog and a namespace inside the Iceberg catalog. So we create the retail return catalog, and then we start creating the return table. So here's the actual return table. So this tracks returns over a certain period of time. And so now I basically see that this is a managed table. So it has table management enabled. So out of the box, you create a table, and you can say, hey, also please manage this table for me. So it takes care of garbage collection, compaction, pruning. So now you can see that you query this table and insert some records into it. So we have inserted a bunch of return records. So you can see it's very quick with the Lightning engine. And then we immediately look at, OK, over a certain window of time, here's my total aggregated returns. And here's the aha moment. So we see this data and over a certain window of time. And now we want to see, can I access this in BigQuery as well for deeper insights? And I immediately see it in the BigQuery console. I have the retail table. I get some details about it. And then I say, OK, great. I want to now query this table. So I go ahead and then basically run a query in my favorite SQL editor in BigQuery. And then I say, OK, great. So I'm able to see the retail returns on Iceberg with the REST catalog. Now I say, OK, I want to learn a little bit more about the return products. So I run an AI generate function using the latest Gemini models on this data. And then I get descriptions of the specific products that were returned over that window of time. So as this works through, it's using the latest Gemini model. So here's the descriptions. And what we'd like to do is now take it a step further. We would like to actually converse with this data and understand a little bit more about retail patterns. So what we do is we start a conversation using conversational analytics. So this uses the conversational analytics agent. So I want to learn a little bit more of this data. So I ask for, hey, what's this data about? What are the fields? So it gives me an overview of the different fields in this data. So it's very easy to use right out of the BigQuery console. So this gives you a quick overview of the schema with details about the specific fields. And then now you want to understand a little bit more. Like, tell me which are the products that are actually really returning, what's the trends, what's the segmentation, and so on. So we ask you a set of questions around that. So could you provide me a little bit more insights on like which product category is actually being returned? And so the agent actually analyzes this data. It's probably looking at the same data on GCS, on your iceberg table, which was ingested from Spark. And then it's going to come up with some patterns on like the returns, plot a histogram, and actually give you some insights on specific product categories. So all of this was pretty straightforward when it comes to like the console itself. So you didn't leave the console. So it's the same console where you had a Spark notebook, and now you're using an agent. So it takes a few seconds, but the insights are pretty interesting. So what you see here is now that the agent has processed it, you can see that the different retail products, what segments they're returned on, you see that specific groups of products are returned more often. And if you're not using an agent, in an earlier ecosystem, you would have built a custom pipeline to figure this out. So you see that shorts and pants are probably the most returned products, and you want to get some more details on why. So once you know that the specific leading category of products, you can then prompt the agent to basically say, hey, can you tell me a little bit more about why this is happening? So what you can actually now ask it for is, hey, give me a specific set of reasons why these products may be returned, or any other such insights. So let's prompt it to understand why the returns are actually happening. It takes a few seconds, but then we can then come through the right insights then to take the right set of actions to mitigate the problem, which was the 5% return rate that we started off with. So now that we see here, it's come up with specific reasons. It talks about the seasonality patterns that were there in that period of time, which was around January. It also talks about specific size and fit issues with certain specific products, and also like specifically travel returns as well. So it gives you specific insights on the return patterns itself. And now it helps the marketing team to actually take actions on this data. So what you can see is that the Lakehouse 1.0 or 2.0 journey that we talked about, we've just seen that here right away. We started with a notebook, loaded the data, got it in iceberg, immediately queried in BigQuery, used an AI function, then used an agent to actually solve the problem. And I did all of this in 8 minutes. So that's pretty neat, right? And now you can actually productionize this agent and expose it to executives in your organization who would like to know why this is happening and build a dashboard on it as well. Furthermore, let's take it a step further. We talked about governance. So we can immediately start looking through this retail data in the knowledge catalog to understand key governance capabilities that you want to, like who's accessed the data, what's the lineage that is needed, what's the data quality, can I get specific insights on this as well? So here's an example where the unified governance, which was a key problem we started off with, one of the key enterprise problems as well, which is being demonstrated with lineage. How was the data generated? What was the different set of engines that are querying it? Furthermore, you can actually see that it's backed by the Iceberg REST catalog using credential vending. You can also figure out where the resources is, where the bucket is, so on and so forth. So what we demonstrated is basically a set of key capabilities all within Google Cloud. But what if we take this a step further and have a cross-cloud journey? Like, imagine a second use case where a college basketball team is actually rebranding their basketball team, and they want to pick a mascot. Now, this particular team that's like the university where they're building this application, it's all hosted on Google Cloud. And however, the data set that they want to access the mascot's data is on another cloud. And it's an S3, it's backed by Iceberg and Unity Catalog. And the SQL analyst on the basketball team, he's like a grad student, so he knows to use BigQuery, he loves BigQuery, and then he would like to query this data cross-cloud. So they have a setup where it's already wired up with Unity Catalog, and we have configured it with Unity Catalog, and we're immediately able to just run a simple SQL command and query the entire mascots table cross-cloud from another cloud on Iceberg. So here's an example where the student is actually running this to get some specific list of mascots from the mascots data set, which is cross-cloud, and then would like to then start running conversational analytics to pick a particular mascot for their basketball team for the rebrand. So I won't go deep into this demo, but what this is demonstrating is the exact set of capabilities we talked about, which we're doing within Google Cloud, can be transcended cross-cloud. So any data, any cloud, any boundaries, in any format. With that, I will kind of wrap up. We announced a bunch of capabilities in our AI native cross-cloud. We talked about openness with zero compromises, and we actually demonstrated it. We also talked about a borderless cross-cloud foundation, which we saw with our mascots use case, built for the agentic era with the conversational analytics. With that, I'll hand over to Sumeet from Viasat.
So I was walking up, and I got to notice that it's time to shift into party gear. Just bear with us for a few more minutes. We're almost there. So first of all, thank you, Vinod and Ahmet, for inviting me to share Viasat's Lakehouse story. What I want to do, though, is frame this as a journey. It's a story that sort of has a journey and an 18-month history. And we've done a lot of work to get our Lakehouse ready. And the primary reason for getting that Lakehouse ready has been to make it AI ready. And so we've done a lot of work just to get to that point where AI automation and real-time decisioning forms the foundation for our company moving forward. And we didn't do this just for architectural reasons. We did this because it would serve as that foundation. So what I would do is talk to you a bit about where we started, where we were, and what changed with our move to Google Cloud as we built our Lakehouse on GCP, and what problems have we already addressed and where we're headed. So that's the rough agenda. But before I dive too deep into sort of data and architecture, I'm not sure how many of you are familiar with Viasat. I see some Viasat folks here, but we're a global technology and communications company with 40 years of history innovating in the advanced communications area. We are a fairly global company. We're spread out in about 74 countries across 90+ offices. That's supported by 7,000 or so employees. So obviously, there's a ton of operational complexity, and I'll talk about the markets we serve. I'll tell you that there are a ton of data complexities as well in our business. But at the heart of our business is our space assets. So we have 23 satellites operating today, 9+ under construction, which includes our Viasat-3 constellation, which is our most modern satellites. The other aspect of our company is that innovation is very core to our DNA. We as a company have over 2,500 patents in the areas of advanced communications, space infrastructure, et cetera. And then, this complexity actually is an opportunity for us, and that's one of the primary reasons we went after the Lakehouse and Google Cloud, is that, we would turn that complexity into opportunity for us by unlocking the data, and that's precisely what the Lakehouse allows us to do. Another important aspect of our business is the markets we serve. So I just wanted you to understand the diversity in our data set through the markets we serve. In our defense and advanced technologies business, we have lots of offerings like tactical networking, mission systems, space systems, cyber defense offerings. And then on the commercial side, under the communication services side, we have a pretty scaled business serving aviation market, and then government SATCOM, maritime, energy, fixed business, as well as I'm just calling it others because there are quite a few, but some of them are advanced non-terrestrial solutions in enterprise and IoT markets. So again, if you look at the dichotomy in our needs, you've got a lot of real-time needs for telemetry coming from satellites and networks, but you also have the need for historical reporting. We are in highly regulated government markets, but we also have commercial needs. We're engineering heavy workflows, but at the same time, we have business and operational workflows as well, right? So evolving our Lakehouse to meet these diverse needs was quite important to unlock the AI environment moving forward. And just to set sort of where we were before we built our Lakehouse on Google Cloud, I would say we had a pretty decent data lake. And the data lake was sort of think of it as a traditional data lake built on top of Trino. But we also had fairly mature warehouses serving each of the businesses I talked about. And then several point solutions that were sort of layered on the warehouses and the data lake that I just talked about. But the lake suffered from consistent performance. It also sort of had become I would say, a dumping ground for data, for the lack of a better word here. We had a governance catalog. We had an enterprise-wide catalog which had a ton of functionality, so you could search metadata, you could find and get access to data, et cetera. But it was somewhat fragmented. That metadata, I don't think, was fully leveraged to the potential that Ahmet and Vinod were talking about, how it could be the foundational layer. And then data was, of course, siloed. The individual warehouses were locally optimized. And what we wanted to do moving forward was set up a global single sort of pane of infrastructure to deal with data in AI use cases and create repeatability. So there were certainly gaps in our AI readiness in the way our infrastructure was set up, right? It was built for an era that served us really well, but moving forward, I think we needed to revamp that. And that's precisely what we did, right? So that's where we sort of started to, or set out to build a modern governed lakehouse on Google Cloud. Now, this is an extremely simplified architecture. We use, anywhere between 30 to 50 services on a single day on GCP. But let me give you a quick highlight for the lakehouse we've built, and a lot of what Ahmet and Vinod talked about, Apache Iceberg. We've been using that for the last couple of years. We're a heavy user of durable storage like GCS. We're a heavy user of BigQuery, and then Iceberg sort of allows us to orchestrate both the warehouse and the lake together. And then we also make use of SQL databases like Cloud SQL, LOIDB, and Span, et cetera. The other aspect of our lakehouse is that we've created a pretty fluid boundary between the telemetry we get from the network and satellites I was talking about, collected through OpenTelemetry and other means, and we collect a lot of that through Kafka as well. But this sort of bridge between the lakehouse and the observability stack, cloud observability stack, is quite unique. It allows us to do a lot of very interesting things on both the observability side, operational intelligence side, as well as traditional machine learning, reporting, analytics, et cetera, on BigQuery. And then we make use of knowledge catalog, which is called Dataplex before, and BigQuery share a lot. So that's really sort of becomes the center point for orchestrating governance across the organization through the complexity of our businesses that I was talking about. And then our machine learning platform is what's now called Gemini Enterprise Agent Platform. So, I'm calling it Vertex AI here, but obviously it's been renamed. And then we're also a heavy user of Looker. So this is roughly what the Lakehouse setup looks like. And it was a very motivated, opinionated architecture that we put together for the types of data sets we have, for the types of problems we wanted to solve. And it's starting to pay dividends. As I said, the Lakehouse really was the catalyst for the AI journey we wanted to be on. And we've started to release agents in production. So there are 3 examples here. The first ones, we call it AI Concierge. And the idea is that a lot of our customers and resellers, used to call us when issues would happen. And we have started to offload basic troubleshooting to them. And it works fairly well in I would say, majority of cases. Of course, we've got to go pretty far to automate that, but it's starting to sort of show results in terms of call volumes, et cetera, particularly from our resellers. Predictive maintenance is a particularly hard problem in our business because we have infrastructure on ships and planes that once they set out, and if something happens, you really don't have means to troubleshoot them, especially if the flight's dark or you lose connectivity. And so predicting the issues well ahead of when they happen is a really, really good problem to solve for us. So we've done a lot of work there, and it's a perfect use case for agentic automation. So I think we're starting to build agents there in terms of detecting dark flights, filing issues, et cetera. So automating that whole process in terms of scheduled maintenance for hardware removal. Last but not the least, we also host a lot of third-party app on our platform. And then agents now have done really well in terms of reducing toil. Every time we have a partner app that requires configuration updates, app updates, agents do take care of that. Humans don't get involved. And then last but not the least, just wanted to motivate on where we're headed with all of this is that, we'll continue to consolidate our data. It's almost there. There is more work to do there. But that's, as I said, is a journey. None of this is a one-shot thing. A lot of announcements, good announcements were made yesterday about agent governance, particularly things like agent identity, registry, agent gateway. You're going to start to use that. We're in the midst of forming our agent governance framework. So I think a lot of what was announced yesterday are helpful. Last but not the least, I think a lot of the examples you saw are sort of single task agents. We want to get into more complex multi-agent systems. And so some of the facilities that, again, we heard yesterday in sessions are helpful for us. Few other things notably to call out are things like autonomous network operations. That's a pretty cool agentic use case where we actually want the network to sort of run by itself. So it's an ambitious vision, but we'll take step at a time, agent at a time, and sort of chomp at it. So really, if you were to kind of take one key takeaway from all of this is that I think data readiness is probably key, or data transformation is probably key before you sort of get on that AI transformation journey. And I think Lakehouse serves as that catalyst to get on that journey. With that, I'm going to hand it back to Vinod to wrap up.
Thank you, Sumeet, for walking us through that amazing Lakehouse journey at Viasat and your future journey with agents as well. That's a wrap, folks. Thank you very much for picking our session over the concert. And as we wrap up, if you would like to learn how to modernize your data onto our agentic data cloud, we have a migrations program. So please, take a screenshot of the QR code. If you would like to build agents at scale, we also have a program as well. And we could work with you on that as well. Thank you, and enjoy the concert.